Hello, welcome to the program with Sam, and this is C++ Lesson 3. Okay, so up until now, all we've been looking at is sort of the variable types available to us and sort of the objects that we can use that would be helpful, but we haven't actually learned how to make other functions. So up until this point, all you'll be able to do is essentially write in the main function what you want it to do. And that's not really feasible as your applications get larger and larger. You're going to want to expand out into other functions. And as it happens, if you've done the C tutorial series, this will sound very familiar because in fact it works exactly the same as writing functions in C. So you can either declare at the start of the file and define later, or you can just sort of declare in the order in which they appear, or just dump them all at the top and then the main function calls them, whatever. The point is the order in which the functions are declared and defined are it's important to the compiler, and the reason for that is that the compiler, when it comes to compiling down the code, works sort of, I would say, kind of sequentially. I guess it's going down the block, like the lines of code, and it's going to say, I've encountered this function, I haven't seen it anywhere up until now, so I don't know what to do. Now, obviously, this is different to Java, where when you create functions, you can do it in any order all over the class file, and when it comes to compiling and running the code, it does it through magic. It knows exactly which function you're wanting to call and when, regardless of the order it's in. But with this particular compiler, it's not possible to do that. So order is important. So, for example, what we could do is we could declare a function. We could declare double add, and it can take a int a and a, or let's do everything in doubles for the sake. So double A and double B. And if we declare it up there, we can then define it anywhere we want. We don't have, we're not then limited. We can do it any order that we want to. So we could have double A, double B, and then this is where we're going to put the body, and it will just be return A plus B, and that's as simple as that. And then obviously the green line's disappeared, and that means that you've declared it up there and defined it down here, which means when the compiler comes to compiling it, it will read that it's declared up here, and then if you if you use it in here, it will then just use the definition from down there because it already knows that it exists. And that's one of the key points to remember. But for the rest of them, what we're going to do is we're going to do double sub double A double B, and this should look very familiar if you've actually watched the C tutorial series, because we did exactly the same thing there. With the goal being to just show how different how you can write your functions in the actual source file. Obviously, by this point, if you've kept up with all of the other programming tutorials and stuff that we've been doing on the channel, then you should already know how to write a function, and you should already know the format in the sense of you have your return value, the name, and the actual arguments, and then the body of the function returning what you want. And more specifically, what's the problem? There is a semicolon there. Yeah, okay, cool. It just took a little while to catch up. But more specifically, you should be aware of the concept of just functions in general and how to write these functions. So here we've essentially written functions for add, subtract, multiply, and divide, the 4 base mathematical functions, and we can use them in our main function. For instance, we could do, although we might need to put include iostream. If we do that at the top, we could then do cout to string, and we could say, I'm not using namespace, we'll just tack in the using namespace so that I don't have to worry about std. Well, that's a strange sentence. Okay, is that because it's from the string header? Quite possibly. And we'll just to string multiply, and we'll multiply 2 and 6, so it should come up with 12. And then at the very end we just do endl. Then if we run that, what should happen is not that. Mul identifier not... Oh, yeah. Of course it is. Because we didn't bother putting that down there. But add can stay at the bottom. And that's exactly what I was just telling us we needed to avoid, was having these declared before we use it in the function. But with add, if we do add instead, it should still work because it's declared up there but defined down there, and that's fine. So that's an important thing to remember when it comes to making your code. So another type of function, and this is sort of more of a way of writing functions, is recursive functions. And these are functions that, whilst executing, will then call themselves, but with new parameters. And the result is sort of like a large tree, almost, if you will, of functions being called and then executed, with the idea being that they're then all brought back together to this original function after all of the sub-functions have finished executing. Now, back in the day, recursive functions weren't really done, to be honest, mostly because back then you didn't have as much memory available, and back then, of course, you were encouraged to use absurd names for your variables, like make them as short as possible because you didn't want them taking up space in the memory. So now, with memory being so readily available and so cheap, recursion is something that's actually encouraged because it's a good way of really making neat, succinct code. So what we'll do is we'll sort of borrow from our C tutorial series, and we'll go through the Fibonacci series example here. So what we can do is we can say, if I just bring that up, and then down here we can do int fib takes, we'll say the int x as the argument, and if x is equal to 0, we're going to return 0. Otherwise, we're going to return... else if. We need the else if there, don't we? Because it could also be 1. So else if x is equal to 1, we return 1. Otherwise, it's just going to return fib x take 1 plus fib y take x take 1 even. X take 2 surely. Yes. No, because that's a Fibonacci series, x take 2. Yeah. So what this code will do is when we pass it, say 10, it'll return 10 take 1 plus 10 take 2. And then those functions will return values less than that as well. And it will keep on going and going and going until it's returning a 0 and a 1. And what we can then do is we can say for int I is equal to 0, I is less than, say, 20, I plus plus, we can see out toString fib I and a space. And what this will do is it's going to go through each number of the Fibonacci series, and it's going to go through each number from 1 to 20, or 0 to 19, I guess, and it's going to output the corresponding number in the Fibonacci series by calculating it using this. So if we then give that a run, it then goes 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and so on and so on. And you can see that it's working if you compare it to the actual Fibonacci series. And that's an example of recursion. It's essentially a function that is calling itself, and that function is then calling itself, and that function is calling itself, but the parameters are different each time, which results in a different value being returned up until the point where you get to the final, in this case 0 or 1, when it then no longer has to call another function, and that way all of the results will be amalgamated into the single final result. That's it for this time. Next time, we're going to be having a look at header files. So I'm going to be showing you how to make header files for your C++ projects, how to make the corresponding CPP files for those header files that you've made, and then how you're going to then use them in your actual project that you're working on. If you'd like to follow me at ProgramSamBlog or follow the blog directly at programwithsam.code.blog, that would be much appreciated, and I will see you in the next one.